Hello and welcome to CG Visuals, my name's Zach, and today we're going to be learning how to create this cool fluid simulation inside of Trapcode Particular to create this water effect. So we'll start with a comp size solid, a new instance of Trapcode Particular, open the designer, change the emitter type to an OBJ and select the sphere smooth option. For the time being we're only going to increase the particle count to 10,000 to get a better idea, reduce the emitter size to 175 and use the emit from faces option. For the motion we'll reduce the velocity to 0 but increase the velocity from motion to 800, significantly reduce the lifespan to 0.2 seconds. And we're going to create a custom size over life graph here. This will just help the particles to fade in and out of existence more naturally. We're going to do something similar with the opacity as well, setting the randomness to 50 and creating another similar graph here, just that we don't get any strange pop-in. We're going to use the color over life option, and nothing too crazy. We're just going to go from a light sort of medium grey and reduce that over time to a slightly darker grey, and you can see the numbers we're using there on screen. We'll enable the fluid simulation, reduce the buoyancy to minus 0.5, increase the random swirl to 5, the swirl scale to 50, the visualize relative density to brightness, the viscosity to 50, and the fidelity to 6, and that will give us the basic settings. Now that we can see our fluids, let's go and add another 0, put that to 100,000. Because they're dying almost instantly, we're not accumulating very many particles, and that's why the performance is able to stay reasonable. To increase the detail, we're going to add a displacement field of 50, fade in time of 0, increase the scale to 15, and the flow in the y-axis to 500. And that will give us our basic fluid volume. We can also give this some shading as well, just to try and make it look more like a volume with the following settings. And now we'll rename this system. We're going to want to keep things named to water volume, because we're actually going to layer up quite a number of systems to create this effect. So we'll create a new system, change it to an OBJ model, again choose the sphere smooth, keep it on edges. This time it's going to emit from speed with a particles per second of 50, and we're going to have the same container size. So we're going to want to modify the motion to outward, reduce the velocity to minus 150, the velocity from motion is only going to be 40. And we'll reduce the lifespan to 1 second with randomness of 35, increased air resistance of 1. The opacity is going to be 0 because this is just a seed system that we'll use to drive something else. So we're going to want an environment gravity of 250, the wind of 100 with some turbulent position. And we're going to give this a displacement field, choosing the radial option, displacement of 25, fade in time of 0, the scale to 25, the evolution speed to 250, and this is going to create some interesting turbulence for our next system. So we've renamed that droplet seed. To keep things organized, we're now going to call this new system droplet stream 01. And so now when we go to the emitter, we're going to choose emit from parent and quite simply choose the droplet seed 01 there as the parent system. We're going to create this custom emit over life graph here, so they only spawn in at the beginning. We'll increase the droplets per second to 200, but put the emission probability down to only 15. As for these droplet streams, they're going to emit continuously. For the motion, we just want them to come out in tight streams, so we'll put the velocity to 0, randomness to 35. We're obviously going to want some gravity from the environment settings here of 1000 with the air density of 0.5, so the air resistance takes effect. We'll go into the particle over life and we can reduce this down to 2. We're actually going to change the particle type to a cloudlet so it's more visible with a life randomness of 50. You can see our streams starting to take shape. They're a little bit too large, so we'll reduce them to 3, randomness of 25. And we want these streams to gradually reduce in size over time. And for the opacity, we're going to choose 100, randomness of 50 with this custom graph here. And they're also going to have color over life, but this time we can just copy the color over life graph that we created for the primary system and just paste that into the droplet streams 01 system. We're going to give it its own displacement field. And we can actually use size and opacity and displacement of 10, 15, 15 with a fade in time of 0.1, the complexity or scale to 15, and the octave scale to 1, and the flow and the y-axis to 1000. So now they're going to sort of act a little bit more like water. A lot of settings there coming together to try and add some more realism. And now we can actually select both of those systems, droplet, seed, and stream, and we're just going to duplicate those systems. So we'll have all the same settings, but this time we're simply just going to rename them to droplet, seed, and stream 02 instead. We're going to create a slight variation of that system that we created. Instead of tight streams, we want it to be more like water droplets. So we'll choose droplet seed 02 as the parent system, decrease the particles per second to 100, and then we'll add some velocity and increase the velocity from motion. So now this variation is more like little speckles of water coming out. We can reduce the size just so the difference is more obvious. When we add them together now, we have tight little streams with little droplets escaping. And if we bring it all together, we can see that our water simulation is starting to take shape. Now we only want the droplets to emit when the water ball is moving, so we're going to change that continuous model to emit from speed, which means we won't be able to see it in the designer until we add an animation. And we're going to add another system here, and we'll call this one water splashes. We'll disable all of the other systems just so the performance stays friendly. We'll change the emission type to a sphere with an emission size of 50, and we'll add a displacement. For the displacement, we'll just put that to 0 so that it isn't inheriting any of the other displacements we created for the primary system. We only want the droplets per second, or the emission per second, to be 15. We're going to choose an outward direction emitter, velocity of 100, randomness of 50, increase the velocity from motion. We're going to make these particles very large because we're going to replace them with a custom sprite. But just for the time being, let's get them to increase in size a little bit more naturally. Now, in order to use the custom sprite, I'm going to import this sprite asset that's included in the description. It's just this water effect, and it kind of looks like droplets when it's sped up. So we'll import that into the layer window, and then we'll go back into the designer. We'll reduce the life time to 0.5, the randomness to 50. We'll choose our sprite. And now, back in Particular, we have to come out of the designer. We can actually choose this sprite that we want to use and then hop back into the designer. And now we can actually see our custom sprite. So we're going to increase the air resistance to 3. I'm going to put the blending mode to screen, and as for the time sampling, we're going to choose start at birth stretch. And now you can see, without any additional effects, it's starting to look like splashing water, which is what we want. We're going to randomize the rotation and increase the random speed rotation to 1. Then we're going to add a little bit of gravity of 1000 and some wind to make it a little bit more interesting. We've got the air density of its default 1. And we're also going to put this to emit from speed as well, and therefore reduce the particles per second to 6, and get an idea of what that will look like. We're also going to choose this preset for the opacity as well, just so it's a little bit more subtle when it disappears. And then we're going to create our final system here, and we're going to call it Liquid Trail. And this one's going to be quite important to help the simulation maintain its shape. So we're going to reduce the particles to 25, reduce the velocity to 0, the velocity from motion will increase to 100, the life time in seconds will be 0.5, the air resistance, quite important, will be 5. To use the air resistance, we'll enable the environment settings, give it a gravity of 750, and an effect position of 25. And then we'll also take advantage of our displacement field and change the size and displacement, the fade in time to 0.3, and also give it some positive value in the y-axis of the flow. Again, you get pretty used to creating these custom size graphs here. We want this to act like a sort of like a water droplet trail, so that's why we've created that graph, and we're just going to fade in and out the endpoints as well. For For this one, we're also using a color over life. This is pretty much standard. We're just choosing a light gray, and then that's going to fade into a slightly darker gray. And we're also going to try and fake some volume using shadowlets with a softness of 80, the opacity of 5, the size is 50, and the adjust distance is 85. And we can also change that shadowlet color to a dark gray as well. We're going to reduce the particle feather to 15, and you can see the effect that we're trying to go for. And again, we're going to change this to emit from speed only, so most of these effects will only be visible when the simulation is actually moving. We're actually going to increase the size of the main system to 200 because it's just looking a little bit too small. And now we can see our system. We can click apply. And to get some interesting animation, we're going to create a null object, call it position locator, and enable the motion sketch. You might have seen us do this before. We'll increase the capture speed to 150. And this is a quick way to get a nice sort of animation. So you can see I'm trying to create smooth motions that kind of have some momentum behind them. So you might want to have a few attempts at that. And then when you have an animation that you're happy with, you can just Control C on the position data, open the position data of Particular, and then just Control V, paste those keyframes. And then we can actually finally see our simulation, probably for the first time. A few extra things we can do here: increase the simulation samples per frame to 2. Obviously we want to enable some motion blur. You might want to try out some different settings for the motion blur, see what works well for you. And I'm also just going to go ahead and increase the particles even further because I want this to have a really sort of condensed volume shape, and the performance is okay, so why not increase the particles? We'll put the color depth to 32. That will work better when we get into compositing. And I've also just added some keyframes for the size for the primary system, just because the fluids tend to disperse the ball more when it's moving, and then when it becomes stationary it looks a bit small. So as the ball is moving I decrease the size, and then when it comes to a stop I've manually, keyframed the size just to try and get it to maintain a consistent size as it's moving around. So now we can actually render this out because it'll be a lot faster to work with if it's pre-rendered. If we want it to have an alpha channel, we're going to want to choose the video codec animation, so we can choose the RGB plus alpha, and we'll render out our asset. You could skip this process, but it's best just to keep things non-destructive and pre-render things wherever possible. So now we can see our pre-rendered asset here. There's actually some enhancements we can add to this. We're going to add a slight opacity boost using curves. We're going to add a bevel edges from the perspective, edge thickness of 70, minus 180 and 0.1 for the light intensity, just to try and add a little extra volume to it. This step is quite important. We're going to add the lumetri color and put the highlights to minus 150 because we're going to be adding our own specular highlights. And we're also going to add a turbulent displacement with this custom expression that you can see on screen, just animating the turbulence in a downwards motion. So you can decide how much of that effect you want to add. And now we'll simply drag our particles comp into the create new comp icon and rename this to export comp. And so now we can start making this look like water. We'll first start by duplicating the particles comp 3 times. I'm going to bring in this custom image here that I just downloaded, has some nice lighting, so give us a good reference for how we want everything to look. And first I'm just renaming this to Specular Highlights, Foam, and Alpha Matte. I'll make sure the foam is beneath the highlights. I'm going to start off with the levels, and the idea here is to just crush those highlights so we get a more defined look. We can also soften the particles with a medium blur effect. And then we'll also add a sharpness effect as well, and a vector blur of 1. That should work for our foam. For the specular highlights, we're going to do something a little bit more interesting. We'll start with a stylized CC plastic. reduce the softness to 15, the height to 25, and the cut minimum to 25. We'll put the light direction to 180 and add the expression wiggle 1,90. And then from the shading tab, we'll reduce the specular to 75 and the roughness to 0.075. Then we'll add an extract effect, and this is going to be to remove everything except for our highlights. And then we can go ahead and add an optical glow from the Red Giant VFX Suite. We'll reduce the amount to 5, make sure we have ununiform scale, and set the size to 15 and 60 respectively to give us those horizontal glows. And then for the alpha matte, we're just going to add a matte choker of 4, 75 and 30 for those settings. Put the alpha matte above the background image. And to actually preview our foam and specular, we're going to change the blending mode to screen and additive. But this will really come together once we add our displacement. So we'll create a new adjustment layer, call it RG displacement, so that when we add our chromatic displacement, which is another plugin from the VFX Suite, we'll choose the alpha matte as the displacement layer. And before we go ahead and change those settings, I'm actually going to change the track matte to use the alpha matte that's directly above the adjustment layer. So then I'll go ahead and put the displacement amount to -300, the softness to 15, and reduce the spread chroma a little bit as well. And we'll change the displacement layer alpha to ignore because we've got our own alpha matte. And then we'll add a second chromatic displacement, choose the alpha matte as the displacement layer, put the softness to 3, displacement to -50, spread chroma to 50 also, and choose cutout for the displacement alpha. And then we're going to copy the turbulent displacement from our particles comp, paste it, and change it to a bulge smooth, amount 75, size 10. And that will be our displacement effect, all layered up. And when we combine it with our specular, you can see the effect starting to come together, especially if we give this a quick preview. We can see all of the post-processing effects that we're using come together. But I still think there's some improvement we could do. So we'll duplicate that alpha matte, but this time put the choke to -75 and 25 to extend the edges. I'm also going to add a white fill layer just from force of habit when dealing with alpha mattes. I'm going to create a new adjustment layer with the time effect pixel motion blur. Again, I'm going to set the track matte alpha to use the alpha matte directly above it. And then we, just like that, we have motion blur. If we reduce the shutter angle to 90, motion blur that now is applied on top of our displacement effect, which does add quite a big difference when we preview this in motion. Of course, you can tweak these settings, but these are the ones I've found seem to work best. We can also take a custom background. Maybe if the background is slightly different, we can just, reduce the specular foam to get a slightly more translucent look. We can preview that again on a different background and see how it looks. And unfortunately, we're starting to lose some of the detail in our water droplets when we do that. So one thing we could actually do to improve the foam is to just borrow our alpha matte that we used for the displacement layer. And I'll simply set this to alpha matte inverted. Then if I just preview the alpha matte here, we'll just come in and create an extract effect. And the idea is to be able to have all the brightness in the droplets while also keeping quite a crystal clear water look for the actual volume itself. And so now if we look at the foam again and go into the levels, we could actually increase the brightness of our water drops whilst also controlling the alpha of the actual water volume itself. And so let's go have a little look at that. And then maybe we could even increase the brightness of the specular highlights here. For the specular highlights, we're actually having the opposite problem where it's actually starting to affect our water droplets a little bit too much. So one really easy thing we can do again is just copy and paste this matte choker and place this before all of our effects. And so now all that's doing is simply just toning down how much highlights we get in our water droplets. And so I think we should re-render everything with those settings, and that should be more of an improvement. And that's part of the fun, creating your own animations on your own backgrounds. So this water simulation is quite versatile. And this project was inspired by the Trapcode Elements pack that we recently released. And the project in particular that I was thinking of when creating this tutorial was the water manipulation project. This was a more simplified version, but after seeing how effective the chromatic displacement effect is, I'm considering trying to incorporate that into the water effects as well. And we'll be covering many other projects inspired by Trapcode Elements so that you can learn how to create these effects for yourself. Anyway, I hope you enjoyed the video, stay tuned for next time, and thanks for watching.